All right, after asking students what problems we needed help on, the results of the vote were the second number 5, number 7, and number 8. This is also my first time using a new recording device. Tell me if the audio quality is a little bit better than it was before. If it's not, I won't keep using this. We're going to start with the second number 5, which is right here. It says if y equals e to the nx, then d n y dxn equals. N is a constant, and this is asking you for the nth derivative. There are two ways to do this problem. One way is to treat this as a constant and start doing derivatives until we see the pattern for what the nth derivative would be. The first derivative, y prime, well, we'll need to use the chain ruler. This is e to the something power. The derivative of e to the something power is e to that something times the derivative of the inside. This is a constant times x. The derivative of n times x is just n. And we usually simplify this to n e to the nx. That's the first derivative. The second derivative, because it says to do n derivatives, is, well, now we're doing the derivative of this guy. And here n is a constant multiplier. So the constant multiple rule says we just leave the constant multiple there and do it times the derivative of the function we know how to do the derivative of. And we'll have to do the chain rule again here. This is e to the nx times the derivative of the inside, which is n. This is n squared e to the nx. The third derivative is, again, we have a constant. This is not a variable. N is a number. N is like 7. If we're doing the seventh derivative, this would be a 7. So a constant multiplier will still stay there, times e to the nx. Again, we're going to do the chain rule here. The derivative of the inside, the derivative of nx is n. This is n cubed e to the nx. And we can keep going until we feel comfortable in our pattern. The fourth derivative will be n to the fourth, e to the nx. The fifth derivative will be n to the fifth, e to the nx. And so hopefully we can see that the nth derivative is going to be n to the n power e to the nx. Guys, this is a really easy problem to do the derivative of. What it's testing is, can you take the skills you have and apply them to a different situation? The answer is clearly A. When we start doing derivatives, you should have just started doing derivatives. There's nothing tricky about the derivatives we're doing, except that n is a constant, right? So some of you guys try to treat constants as variables sometimes, and that goes very poorly. All right, number 7. It says, determine the points on the curve where there are horizontal tangent lines. Write them as ordered pairs. Then write the equations of the horizontal tangent lines. Okay, so we have this function. It's an implicitly defined function. This is actually in a circle. And it wants to know where are there horizontal tangent lines. The non-calculus way to do it would be to, oh sorry, this is not a circle, this is a hyperbola. The non-calculus way to do it would be to graph it, but we're not going to be graphing it because we know calculus and it's much easier to do using calculus. We want to know where there are horizontal tangent lines. So there's some function, it's a hyperbola in this case, and we want to know where are there horizontal tangent lines. The horizontal tangent lines, what has to be true about them is that the slope is 0. And we know how to find the slope of tangent lines. The slope of tangent lines can be found by finding y prime. So what this is really asking us to do is to see where is the derivative of the function equal to 0. We can find y prime by doing implicit differentiation. The derivative of y squared is 2y times the derivative of the inside, which is y prime, minus 2x minus 6 equals 0. We do the derivative on both sides, and we solve for y prime. So we add 2x and 6, and we're going to divide by whatever is multiplied by y prime. So it's going to be 2x plus 6 divided by 2y, that is y prime. And what we're looking for is, where is the derivative equal to 0? So where is this equal to 0? You should know that when you have a fraction and it's dividing to make 0, the way you divide to make 0 is the numerator needs to equal 0. 0 divided by any number is 0, as long as the denominator is not 0. So what we're looking for is where is 2x plus 6 equal to 0, because if 2x plus 6 is equal to 0, then we'll get 0 over 2y, which will be 0 as long as y is not 0. So 2x plus 6 equals 0 when x equals negative 3. That is the x value where the tangent line will be equal to 0. This is x equals negative 3. It asks us to write as ordered pairs. That means we need to find the points, point or points, and so we need to take x equals negative 3 and plug it into our equation to solve for y. Y squared minus negative 3 squared is 9. Negative 6 times negative 3 is plus 18. That needs to equal 10. And so this gives us another equation. This is a quadratic equation. We can get y squared by itself. Y squared equals, we subtract 18, add 9, and we get y squared equals 1. Y equals, when you take the square root on both sides, plus or minus 1. This is because 1 times 1 is 1, negative 1 times negative 1 is also 1. So the equations, or the points where the equation of the tangent line is going to be horizontal, the points are negative 3, comma 1, and negative 3, comma negative 1. Those are the points where the lines are tangent. And it also said to write the equation of the horizontal tangent lines. Well, the equations of the tangent lines are going to be y equals m times x minus x1 plus y1. So we're going to get y equals, the slope of a horizontal tangent line is 0. And I'm not even going to fill this in because 0 times anything is 0. This is y equals negative 1. The other equation, that's for this point, the horizontal tangent line going through this point is y equals negative 1. The other tangent line is going to be y equals 1 because the y value is 1 and the slope is 0. These are the two equations of the horizontal tangent line. Okay. Number 8. It says determine the points on the curve where there are vertical tangent lines. Okay. Well, vertical tangent lines, let's see, what shape is this? This is a circle. This is a circle. Circles will have vertical tangent lines when the slope is undefined. So we need to find a place where the slope is undefined. And to find the slope of the tangent line, we need the derivative again. So we're going to do implicit differentiation. 2x plus 2 plus the derivative of y squared is 2y times y prime. The derivative of negative 4 times y is minus 4 times the derivative of y, which is y prime. This equals 0. I'm going to move all the things that don't have y prime over to the other side. Negative 2x plus 2. And I'm going to factor out the y prime. So 2y minus 4. Y prime is going to equal negative 2x plus 2 over 2y minus 4. So the question is, this is the slope of all the tangent lines. The question is, when will this have an undefined slope? Well, the slope will be undefined if we're dividing by 0. So this is, in the end, really just asking us, where is 2y minus 4 equal to 0? And that happens when y equals 2. Similar to last problem, it asks for the points on the curve. So y equals 2 is not a point, that's the y value. To find the x value, you should be able to predict where this is going. To find the x value, we need to plug in y equals 2 into the equation. And we'll do that. X squared plus 2x, y equals 2, so plus 4 minus 8 equals negative 1. I've just plugged 2 into y here and here. So this is a quadratic equation. This time we can't just get x squared by itself because there's a second x, so we need to factor or use the quadratic formula. X squared plus 2x. We're going to get negative 4 plus 1 is minus 3 equals 0. And this can be factored. X plus 3 times x minus 1 equals 0. X equals negative 3. X equals 1. And with both of those, the y value was 2. And so the points are -3, 2, and 1, 2. Those are the 2 points that will have tangent lines. All right, those were the ones that got the most votes. Hopefully